All right. So in this last lesson of this regression analysis unit, we're going to be modeling data with sinusoidal functions. All right. So the general form of sinusoidal regression model is, so y is approximately, all right, so you notice here we have a, b, c, and d as our parameters, okay, because each one of these mean a different thing when it comes to sinusoidal functions. The other thing is that, we're going to use the sine function, but actually in reality, whether we use sine or cosine, it actually doesn't matter, right? We're going to get the same kind of result where it comes to a graph, right? Now, the one thing that we need to note is that we need to use what they call radian mode when performing sinusoidal regression. So I'm going to show you how to check and make sure that your Desmos is in that mode. All right, cool. So let's just jump into the first example here. So in 2011, the Singapore Flyer was the largest Ferris wheel in the world. All right, so the following table gives the height of a rider from the ground at different times. Okay, so let's say that. All right, so let's first punch this into the Desmos table. All right, so I'm just gonna pull up Desmos. All right. All right, so let's add in a table. Okay, so 0. Okay, so it looks like these jumps are consistent. There we go. This is 49, 295, or 41, 5, 49, 5, 41, 5, and 49. All right, cool. All right, so let's take a look at our x value. So it goes from 0 to 74. Now, so this is a sinusoidal function, so it's going to actually go on forever. So we can just go from 0 to, let's go 0 to 100. And then for my y values, right, it goes, looks like it goes from 49 to 540 is your maximum. So in terms of height, yeah, let's just go perhaps from negative 10. I'm just going to punch in a height of negative 10 to, we even just go 600. All right, so these are the points. Now you can see that, yeah, it looks like it's going to model the sinusoidal function. So for next up, to find the actual equation, I'm going to punch in y subscript 1. It's approximately, all right, so what was it? It was a sine. So I need to get my sine function. So again, I'm going to go to functions here and trig and the sine function. All right. Again, it doesn't matter if you use sine or cosine. You're still going to get the same graph, just the different parameters, perhaps. But anyways, let's go with sine just to be consistent. And let me just pop this back here. So yeah, so a sine b bracket x1 plus c. Actually, one sec, guys. I just want to. I was playing around with this the other. Yeah, the b is in the brackets. Okay, so please forgive me. I'm going to change this up a little. Instead of the b being outside, I'm just going to put it on the inside of the brackets like that. Save that again. Okay, so yeah, so in this case, when we type this in, I'm going to put the b inside the brackets, which is what we want. All right, so x subscript 1, right arrow, plus c, right arrow, plus d. All right, and let's just change the color here. Okay, so yeah, so if you look here, these are our points. You can see that it does model sinusoidal function. If I scroll down here, I believe you can see the correlation coefficient is a 1. So it's 100%, which means that these points that were plotted on the table, all 100% of them go through this function. Right? And it actually makes sense because this example here has to do with the Ferris wheel. So the speed of the Ferris wheel is consistent, right? So these heights should be the same in terms of, or not the heights, the point should be fairly consistent when it comes to a curve. All right. All right, so these are my parameters. So I am going to write that down here. All right, so the height, let's call it h, is going to equal. So let's do a little better job of writing. All right, so h equals, my a value is 246. Sine, bracket, my b value there is 0.169, so let's just round it to 17. X minus the c value is negative 1.57 plus d, which is 295. Okay, so this is my linear, or it's not linear, my sinusoidal regression function, all right, that models this data. I just realized though that I forgot to go through how to make sure this is in radian mode. Right? Like I said in the in this note right here, it says use radian mode. All right, so before you do all this stuff, yeah, what you want to do is you want to go to the graph settings and make sure that this down here is clicked off radian. All right, if it's in degrees, just see what happens. No, okay, it doesn't do anything, but it will change the parameters if it's in degree mode. Actually, yeah, notice that when I toggle this, yeah, so if I toggle this back and forth, notice that the b and c values change, right? So if it's degrees, my c value is negative 90, means that I want it in radian mode. All right, so I want these values here. Okay, cool. All right, so what do we got here? Okay, so we got the equation of the regression model. All right. So part B, actually that's pretty much the only other question, is what are the first two times that the height of the rider is 320 feet? All right. So my height, which is my y value, is 320. So I want to find the first two times. Okay. So that would be there and there. Okay. So at 9.8, I believe it's seconds. All right, it doesn't give the time. I'm just trying to think. No, if it's a big Ferris wheel, they don't want to be doing that. They don't want the time in seconds. They want it in minutes. So this must be in. Just like that. Yeah, the time has to be in minutes, not seconds, or else you get really, really dizzy and you start throwing up. Okay, so anyways, time in minutes. Let's just go back here. So 9.8. 9.8 minutes. And the other height there would, so it goes up, comes back down, 27 after 27.2 minutes. All right. Cool. All right, so those are the first two times that the rider is at a height of 320. All right, guys, so that's sinusoidal regression. Ciao.